Hello everyone. On this video we will go over examples of finding the area of a plane region. Okay, so hopefully you have a decent understanding of the previous video where we went over the concepts of it. So now let's apply it to the problems. Okay, so for this example, let's say if we're using 4 subintervals. Oh, don't need that comma. For f of x equals 19 plus x squared on the interval from 2 to 3, find the upper sum. And we're going to round it to the nearest hundredth. Round to nearest hundredth. Or 2 decimal places. Alright, so how do we get started? First thing we do is look at how many subintervals we're going to have. Okay, so here, since we're using 4 subintervals, we're going to make our n equals 4. Okay, so now that we have our n, we need our delta x. Okay, so if you remember, by definition, delta x is equal to b minus a over n. Okay, so in this case, your interval from 2 to 3, your a is equal to 2, and the 3 is your b. So you get 3 minus 2 over 4, which is 1/4, or you can make it 0.25 if you like, or you could leave it as 1/4, either one. But I'll be using 0.25 for my delta x. Okay, so what does this tell us? This means that starting at 2, instead of going directly from 2 to 3, we're going to move up. Instead of one big interval, we're going to make 4 smaller subintervals that all have a distance of 0.25. Okay, so the subintervals will be, again, we're starting at 2, but adding 0.25 to that, we're going from 2 to 2.25. Okay, and then we're going to go from 2.25, we're going to add 0.25 to that, which will give us 2.5. And then we're going to go from 2.5, we're going to add 0.25 to that, and that will be 2.75. And then we're going to go from 2.75, we're going to add 0.25 to that, which would give us 3. Okay, so these are all of your 4 subintervals. So instead of just going from 2 to 3 directly, we're going from 2 to 3 in intervals of 0.25. All right, so now that we have that out the way, we have our subintervals. What do we do next? Well, we have to figure out if our f of x is either increasing or decreasing on that interval. Okay, so if you plug in 2 and get a value, if you plug in 3 and get a value, you'll notice it's increasing from 2 to 3. Okay, so you notice f of x increases from x equals 2 to x equals 3. So we know the upper sum uses the right endpoints. All right. So if you go back to the previous video that goes over all of the explanations for the area of the plane region, you'll see that once again the drawings aren't necessary, but it helps you visualize. So we're going to go ahead and show why we know the right endpoints are used. Okay, so if your function is increasing, remember this is just a quick little idea. Well, I won't put it there because I'm going to be using that area, but this is just to show you the idea behind it. Okay, so since our function is increasing from 2 to 3, okay, we're going to show an increasing graph. Okay, now since we have an upper sum, we're not going to have the rectangles below the graph. We're going to have them above the graph. So that means if we're going to go above the graph, this is how they are going to look. Okay, so all of your right endpoints are going to be touching the graph. So again, we're going to start at x equals 2, so that's your x0 equals 2. We're going from 2 to 2.25. So your x sub 1 is 2.25. Your x of 2, 2.5. Your x sub 3 is 2.75. And your x sub 4 is 3. Okay, so we know starting at the right endpoints, we're not starting at the left, we're starting just where the right endpoints intersect the graph. So we're starting at 2.25, 2.5, 2.75, and 3. Or you could just look at your subintervals, 2.25, 2.5, 2.75, and 3. Okay, so that's why the graph isn't necessary, because as soon as you know you're going to be using the right endpoints for an increasing graph to find your upper sum, you just have to identify those right endpoints. So those are the values you're going to be plugging in. Okay, so now let's go ahead and go to our formula. So the sum from I equals 1 to n, f of c sub I, delta x sub I. So let me clean that up a little bit. That should be c sub I. There we go. Okay, so we know that we're going to go from 1 to n equals 4 because we identified that earlier. So I equals 1 to 4 of our f of c plus I, well, c sub I. Now, since we're using x sub i's here, we're going to go ahead and just have that as x sub i's value. So our f of x sub I is going to be 19 plus x sub I squared. Now, you could make those c sub I if you wanted to, but just to keep it close to our original function, I just made it x sub I. And our delta x sub I is 0.25 because we already figured that out. Okay, so now we use this formula by plugging in I equals 1, I equals 2, I equals 3, and I equals 4. Okay, so that's going to equal, just continuing this down here, you have 19 point x sub 1, well, 19 plus x sub 1, 19 plus x sub 1 squared times 0.25 plus 19 plus x sub 2 squared times 0.25 plus 19 plus x sub 3 squared times 0.25 plus 19 plus x sub 4 squared times 0.25. Ran out of room there, but hopefully you see what I was trying to write. Okay, so we plug in our x sub 1. So that's, well, actually, first we're going to factor out the 0.25, so we don't have to keep writing that over and over again. So we factor the 0.25 out of all of those. Okay, so first we have our 19 plus x sub 1 is 2.25. 2.25 squared plus, we have our x sub 2, so that's 19 plus 2.5 squared plus 19 plus our x sub 3 is 2.75 squared plus 19 plus 3 squared, our x sub 4. Okay, so that gives us our 0.25 that we factored out. 19 plus 2.25 squared is actually 24.0625 plus 19 plus 2.5 squared is 25.25 plus 19 plus 2.75 squared is 26.5625 plus 19 plus 3 squared is 28. Okay, so each one of these gives us the area for each triangle. Okay, so by the time you add all these together and multiply by 0.25, it is approximately 25.97. And that's when we round it to the nearest hundredths, and that's our upper sum. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Okay, so for example, let's say once again using 4 subintervals. Find the lower sum for f of x equals 16 plus 4x squared on the interval from 1 to 2 and round it to the nearest hundredth. All right, so once again, where do we start? Well, we start by looking at how many subintervals we're going to have. So let me see if I can clear this up a little bit. Yeah, a little bit better. Okay, so we know since we're going to have 4 subintervals, we're going to make n equal 4. And we need to know our delta x. So our delta x, remember that's b minus a divided by n. So in this case, your a is equal to 1, and your b is equal to 2. Okay, so that's 2 minus 1 divided by n. Oh, divided by 4, because we already know what n is, which is 1/4 or 0.25. Okay, now 0.25 is common, but it's not always guaranteed that your delta x will be 0.25. It is very common, but it's not something that you can just automatically from the beginning assume that it's going to be 0.25. So you always want to work this out in case the problem changes it up a little bit. Okay, so we have our n for our 4 subintervals, and we have our delta x. Okay, so that means, so our subintervals will be, we're going to start at 1, and we're going to move up 0.25. So if you get 1 plus 0.25, that will be 1.25. Okay, now starting at 1.25, again, we're going to move up 0.25. So 1.25 plus 0.25 is 1.5. Okay, so starting at 1.5, we're going to move up another 0.25. So 1.5 plus 0.25 is 1.75. And 1.75, we're going to move up another 0.25. So that would be 2. All right. So now what do? Well, we have to find out whether or not it increases or decreases on this interval. Okay. So we can see here that the interval increases because if you plug in x equals 1, and if you plug in x equals 2, you notice that x equals 2 is larger, a larger value. Okay. So we know that the function increases over the interval from 1 to 2. So the lower sum uses left endpoints. Okay, so how do we know that? Well, let's go ahead and do a quick little sketch just to show you why that will be the case. If we have our graph here, we know it's increasing, and we're looking for the lower sum. Okay, so when you're looking for the lower sum, the graph, all of the rectangles have to be below the graph. If you're looking for the upper sum, all of your rectangles have to be above the graph. So if it's increasing, and we're looking for the lower sum, remember, if you do the upper sum, then it would be over the graph, and the right endpoint would be touching the graph. But doing the lower sum, you can see that the left endpoint would be touching the graph. Okay, so these are all of the endpoints touching the graph. That means your x of 0 is going to be 1. Your x of 1 is 1.25. Your x of 2 is 1.5. Your x of 3 is 1.75. And your x of 4 is 2. Okay, so we're just going just our regular intervals. So each rectangle is in their own interval. Okay, so from 1 to 1.25, 1.25 to 1.5, and so on and so on. Okay, now since we're using the left endpoints, again, you didn't have to draw the graph out. This is just kind of a visual. we know that we're going to use the left endpoints. We're going to use all of the left values. All right, so what's the actual formula we're going to use? Well, we're going to use the sum from I equals 0 because we're starting right at 1. So we're going to go from I equals 0 since that's x sub 0. So I equals 0 to 3, because remember our n is equal to 3, of f of c sub I delta x sub I. All right. So what formula does that give us once we plug everything in? Remember, this is our f of x. So again, you could use c sub I here if you wanted to, but we're going to just stick with this using the x sub I. So you have the sum from I equals 0 to 3 of 16 plus 4 x sub I squared. All we did was change the x to x sub I times your delta x, which is 0.25. Okay. So once again, we're just going to move this I up one at a time from 0, 1, 2, and 3. Okay, so just going to bring this down here. Okay, so you have 16 plus 4 x sub 0 squared times 0.25 plus 16 plus 4 times x sub 1 squared times 0.25 plus 16 plus 4 times x sub 2 squared times 0.25 plus 16 plus 4 x sub 3 squared times 0.25. Okay, so here you see that all we did was just use the summation to go I equals 0, I equals 1, I equals 2, and I equals 3. Alright, so we're going to go ahead and replace the x sub 0 with 1, x sub 1 with 1.25, x sub 2 with 1.5, and x sub 3 with 1.75. And we're going to go ahead and factor out that 0.25 again, so that's out of the way. Okay, so you have 16 plus 4 times 1 squared plus 16 plus 4 times our x sub 1 is 1.25 squared plus 16 plus 4 x sub 2, so that's times 1.5 squared plus 16 plus 4 times x sub 3 squared, which is 1.75 squared. Alright, so if we go ahead and simplify each one of those terms, you don't need to rewrite that. We can just go ahead and simplify that one. So 16 plus 4 times 1 squared is just 20. Plus 16 plus 4 times 1.25 squared, this is 22.25. Plus, we solve that one, you have 16 plus 4 times 1.5 squared, that is 25. Plus 16 plus 4 times 1.75 squared is 28.25. Okay, so if you add all these together and multiply by 0.25, you will get approximately 23.88 if you round it to the nearest hundredth, and that is your lower sum. Okay, so before we calculated for the upper sum, this one we're calculating for the lower sum of our area of our rectangles. Okay, so that's if you get the area of this rectangle, this rectangle, this rectangle, and this rectangle, add them all together, this is what you get. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. All right. So for this example, we want to know what is the upper sum for f of x equals 14 minus 3x squared on the interval from 1 to 2 using 4 subintervals. And again, we're going to round to the nearest hundredths. Or 2 decimal places. All right, so starting off, we're going to start off the same way we did before. How many subintervals? Okay, so we're using 4 subintervals, so we know that our n is going to equal 4. Next, we find our delta x, which is b minus a divided by n. So here, your a is equal to 1, and your b is equal to 2. So that's 2 minus 1 divided by 4, which again is 1/4, which is 0.25. Again, a lot of times it'll be 0.25, but you still want to calculate it because they might throw a little different delta x in there. And you don't want to go through all of that work when all you had to do is this very simple calculation for delta x at the beginning. All right, so we have our n equals 4, and we have our delta x. So now we find our subintervals. Okay, so the subintervals will be, again, we're going to start at 1, and we're going to move up 0.25. So that's from 1 to 1.25. So starting at 1.25, we're going to move up another 0.25. So that's 1.5. And starting at 1.5, we're going to move up another 0.25. So that's 1.75. And starting at 1.75, we're going to move up again the 0.25, and that will put us at 2. Okay. So the one way you can think about it when your delta x is 0.25 is think of it along the lines of money. If that's a quarter, if you're starting at $1, you have $1 to $1.25, $1.25 to $1.50, $1.50 to $1.75, $1.75 to $2. So you can think of it that way. But that's helpful for 0.25 for your delta x. All right. Now, the difference between this question or this example and the previous two is that if you notice, when you plug in x equals 1 and x equals 2 into your f of x, it's decreasing. The value for 1, x equals 1, is larger than the value for x equals 2, so it actually decreases. So the function decreases from x equals 1 to x equals 2. Okay, so the upper sum uses the left endpoint. All right, so once again, we're just going to do a quick little sketch to kind of help visualize. All right, so if we have our X and Y axis here, okay, so since again we know it's decreasing, it's going to be decreasing like that. Okay, so it's a decreasing function. All right, so once again, we're looking for the upper sum. So that means our rectangles will be above our function. Okay, so for this rectangle to be above the function, you'll notice that all of the left endpoints are actually touching the graph. Okay, so if your left endpoints are touching the graph, you're going to use your left values. Okay, so for this one, this is your x sub 0, which is 1. Your x sub 1, which is 1.25. Your x sub 2, which is 1.5. Your x sub 3, which is 1.75. And this is your x sub 4, which is 2. Alright, so since we're starting with our left value, that's your x sub 0. So it's the sum from I equals 0 to 3 of f of c sub I. Well, don't really need a parenthesis for that delta x sub I. Okay, which is equal to the sum from I equals 0 to 3. Your f of, well, we'll call it x sub I, is going to be just replacing the x with x sub I up there. So that's 14 minus 3 x sub I squared times 0.25, since that's your delta x sub I. All right. So we're just going to go ahead and replace our x sub i's with the x sub 0, x sub 1, x sub 2, and x sub 3. Okay, so we have 14 minus 3 x sub 0 squared times 0.25 plus 14 minus 3 times x sub 1 squared times 0.25 plus 14 minus 3 times x sub 2 squared times 0.25 plus 14 minus 3 x sub 3 squared times 0.25. Okay, so once again, we just replace the I with 0, 1, 2, and 3. All right, so we're going to go ahead and factor out the 0.25, so we don't have to keep writing that over and over and over. Okay, so the x sub 0, we're going to replace that with 1. So you have 14 minus 3 times 1 squared plus the x sub 1, replace that with 1.25. 14 minus 3 times 1.25 squared plus the x sub 2, replace that with 1.5. 14 minus 3 times 1.5 squared plus, and the x sub 3, replace that with 1.75. 14 minus 3 times 1.75 squared. Okay, so from here, we have our 0.25 that we factored out. Okay, so 14 minus 3 times 1 squared is just 11. Or 14 minus 3. Plus 14 minus 3 times 1.25 squared is 9.3125. Plus, now we do this one, 14 minus 3 times 1.5 squared is 7.25. Plus, now we do this last term, 14 minus 3 times 1.75 squared is 4.8125. Okay, so if we add all these together and multiply by 0.25, we end up with approximately 8.09 as our upper sum. All right. So that's how you would approach the upper and lower sums based on how many intervals you have. Okay, so hopefully this video made sense, and I will see you on the next video.